Okay, so this is called TempleOS because you hit F7 and God talks. Nor voices increase measurable. That's tongues. Anyway, so it's an operating system. The command line feeds into a C compiler. So we have, well, the integer types are different. U8 count, I64 and I60. It's a 64-bit. 1 I less or equal n I plus plus. If it hits a string, it's a printf %d. If it hits a string, now if I say count to 10, counts to 10. It's pretty fast. If I say count to 1,000,000, how long does this take on your machine? Ready? Here we go. 1, 1,000, 2, 1,000, 3, 1,000. It's pretty damn fast. The screen update is cheats. I don't know if you want to call it cheating. It only updates every once in a while. Anyway, so unassemble function. Let's say who minus r. Who minus r. There's a count function. We can say unassemble function count. This is 64-bit assembly code. It's not an interpreter, it's a compiler. It uses register variables. Right here is a register variable, RSI. I is our RSI, N is our DI. So I wrote a compiler. I wrote a fucking compiler. Anyway, front end, back end, middle end. There's a lecture or two on the compiler. Anyway, let's talk about HolyC. So how about I use another window? Go to documentation, HolyC. Let's just talk about all the features. So you have U8, I8, U0. U0 is like void except it's zero size. That's a big difference. So in a structure you can, let's say you want to do a bulk write of a record to disk and you want to just copy a structure. You can put a label with 0. F64 is double. There's no F32. We have a 100,000 line limit. Maybe the committee wants to put F32 in there. The compiler's 20,000 lines. It's just in time, ahead of time. Anyway, way back when I started, I said, gee, I have a command line. What am I going to do? Well, I don't like Unix scripting because I can never remember it. I'm a programmer, not an administrator. I know C, I don't know scripting. So I said, why don't I just use C? So I said, okay, we're in luck. C. You know what? I'll use default arguments from C++. I didn't do everything from C++, just some things. Whoa, what? Do I really need those parentheses? So I said, no. What's the side effect? You have to say address a dir. If you use function pointer, it's address. So once I changed the syntax, I changed everything. So for example, 1 or 2. I think this example will be a different result. I put shift as exponent, highest priority. Anyway. I changed the operator precedence. If you want to know, then I got to thinking, well, if I'm moving up off the bottom, how do I do command history? Well, why don't I put my command history on why don't I hit a key, Control M. Now you have little macros that are like command history. So now why don't I put graphics on a little macro? Whoa! These do something slightly different. They spawn a new task. That's an option. You can do plus pop up and it'll spawn a new task. Otherwise, it sends text to the command line. So that's how this works. So a macro, an icon is basically a macro with a picture sprite. Okay, so getting back to here, so you can have default arguments. I went ahead and doesn't have to be at the end. What do we have? Put char. So like I said, if it hits you can see here printf, put char. You can do that. You just have a string as the first part of a statement. The way I explain this is go ahead and look at the compiler. Here's the statement parser. You can see when it parses a statement, this is when it parses a statement, it hits the if it hits a block, then it does a lex to skip the left brace. Then as long as it's not a right brace, it does a recursive call to itself to parse more statements. Then if it hits a comma, anyway, so this while loop is for a statement. Hitting comma, you can have commas for a statement. So the reason I'm mentioning this is towards the bottom, there it's handling keywords. Now if it hits something that's not a keyword, it checks if it's a go-to label, if it's an identifier not in the hash table, makes a go-to label. Here's where it gets interesting. If it's a string or it's a character, then it does a function call to printf. Okay, so that's how that works. Now the other issue is, let's say you do ABC. Normally you can only put one character, but the way we operate is, whoa, hold on a second. Oh, that printed, I'm sorry. That's because we said if it hits that, it prints. Okay, so I is a variable. Whoa. Well, what did I do? I'm sorry, I screwed up again. What? What the hell is going on? Okay, I. Okay, I is 41, 42, 43. That's A, B, C, and ASCII. So this is a common thing in assembly language. You sometimes deal with some ASCII and a register. So getting back to this, so it's not just put char, it's put chars. In this operating system, it's put chars. So the lexical analyzer returns whether it's an identifier, a number, or a string. And what I did is I made my lexical analyzer, instead of returning just a character, it'll return up to 8 characters. So if we go to put chars, you can see it prints and then shifts and then prints and then shifts. So that's how that works. My BuzzFizz is kind of classic. You won't see a BuzzFizz this cool. This is the coolest BuzzFizz you'll ever see. FizzBuzz. Assembly, and it doesn't use a divide, it uses a counter. That's the best BuzzFizz ever. Anyway, oops. So what else do we have? So put char, ampersand when dealing with function pointers. Typecasting is postfix, and I don't even know what it's equivalent to. It just clobbers in the compiler, it just clobbers the type and gives it a new type. Anyway, there's no main. You saw over here when I guess we're over here. There's no main. Any statement outside executes immediately. So if we do ctrace, trace the compiler. If we say directory, what is that doing? It's loading some default arguments that's hidden, and then it's calling the directory. Okay, so where were we? There's no main. Any function, any call outside of any code outside of a function executes immediately. It's kind of like BASIC on an Apple II or a Commodore. If you have a line number, it's saved. Otherwise, it executes immediately. Anyway, what do we have here? So there's kind of a funky. It doesn't have bit fields, but there are some standard sub-integer fields. If you want to get a byte or a word off of an integer, you can do it pretty easily. It's automatically already defined for the standard. Anyway, if you have a variable number of arguments, just like this in C++, you have some automatic variables declared argc and argv. They're type integer and integer array. If you pass it a float, it leaves it as a float. Doesn't convert it to integer. I'm pretty sure. Yeah, that's right. Now, if we have if you want to print a graphic text, you can take your argc, argv from your format statement, pass it to the string print, and then put it. If 13 is less or equal to age less than 20, it's a teenager. We have conditionals with multiple parts. The switch statement is always, don't do a big range. Always, it doesn't do sparse switch statements. Okay, you can have ... No bound switch. This is faster. It doesn't check if it's within range. That's dangerous, but if you know what I'm talking about, it's a little faster. Sub-switch statements, you can start putting together code for this has code printed for odd and even. No one used warn. Okay. The rest of this is kind of minor. You don't need to know it. You can have integer. You can have interrupt routine by adding an interrupt keyword. It has an exponent operator, backwards / What do you call that thing? I forgot. Backward quote, something like that. There's no question colon. There's no type def. Here's the new precedence. Bit shift is exponent. There's no defined functions. I don't like those. No type def. I didn't need those, so I decided, why do I have them? Type checking. No type checking. I don't like type checking. No include always uses a string. There's a union is like class. This is kind of cool. I shouldn't tell you. It's pretty arcane. Exceptions. Okay, so the exceptions, it has exceptions, but they're different. Go ahead and look at the code. Size of no continue. If you can have a multi-core lock that does an assembly lock prefix. You can free a null. The stack does not grow, so you need to use the heap. unless you're crazy. Only one base class. There's some new codes in the Printf. Okay, this is kind of weird. In the compiler, anything that gets loaded in a register gets up converted to 64 bits. And the register variables are 64 bits and inner operations are 64 bits. So if you declare a small integer and then expect it to stay small, that's not what happens. It gets okay. So I was going to explain something. This is one of my at Ticketmaster. I learned some tricks. Negative displacement. Okay, so we have a class. First name, last name, address, city, state. Okay, now if we look at the unassembly of that, if we look at the unassembly, you'll notice over here it loads a 20 off RSI, a 40 off RSI. And look at this, when it loads 80, it has to do 4 bytes. CO, 4 bytes, EO, 4 bytes. That's because bytes, there's an assembly instruction for bytes, but once you hit bigger than a signed byte, it has to go to 4 bytes. Now, what I did is said, why don't we start with a negative, because these are signed. And so you can make signed offsets on the structure, and then they stay small. So you put this $sign equals minus 128, and then you have to get tricky. You have to, when you load a pointer, you have to add 128. And anyway, so you can. This is an optimization nobody else can do but me. I am the greatest. I did a no bound switch. I am the greatest. This is divine intellect. God says I should maybe end my videos with a God quote. Oh, let's talk to God. Out Macedonia intrude goods, raisest affrighted enmities, adapt anger, forgiven, given way, Grecian, safe, supereminent, cedars, wheresoever indignant, vessels known, murmur hundreds. Okay.